Hello and welcome. Let's do some examples from chapter 3 on probability. So this example has to do with sample space. So the sample space S is all the ordered pairs of two whole numbers. The first from 1 to 3 and the second from 1 to 4. For example, parentheses 1 comma 4 is one of the members of the sample space. Okay, so we're asked to find the whole of the sample space. All right, so we have basically the sample space is formed out of like pairs of numbers, and it says the first one comes from the numbers 1 to 3, so we have choices 1, 2, and 3. And the second from 1 to 4. So here we have the choices 1, 2, 3, and 4. All right, so basically we have to pair up all of these with all of these. Okay, so we can start listing them. We have 1, 1, 1, 2, 1, 3, 1, 4, then 2, 1, 2, 2, 2, 3, 2, 4, and finally 3, 1, 3, 2. Let me make some room here. 3, 3, and 3, 4. Okay, so this is the sample space for my problem. All right, now let A the event be the event the sum is even, and be the event the sum is prime. All right, so let's list all the possibilities in event A. Okay, so we look at all the entries in our sample space and we list the ones for which the sum is even. Okay, so basically if you have two even numbers and two odd numbers together, that was going to give you an even sum. All right, so let me see if I can squeeze them into here. All right, so we have 1, 1. That's going to give me an even sum. 1, 3. 2, 1. No, 2, 1 doesn't. 3, 1, 4. 2, 2 gives me even. 2, 3, 2, 4 gives me an even sum. 3, 1. Right? 3, 2, and 3, 3. All right, so those are the occurrences in event A. All right, event B, the first number is prime. So prime number is a number that divides only by 1 in itself. 1 is not considered a prime. Right? 2, 3, 5, 7. Here from like the first numbers here, 2 and 3 are prime, but 1 is not. Okay, so the first number is prime is going to be everything starting with 2s and 3s. Okay, so let's see if I can squeeze them into here. I'm gonna do green. So 2, 1, 2, 2. 2, 3, and 2, 4. 3, 1. 3, 2. 3, 3. And 3, 4. All right, cool. Let's look at the next problem. PA. So here's the probability that event A is occurring. So this would be how many occurrences are in A divided by how many occurrences in the whole of the sample space. So I have 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right. So 6 over 12, or you can say 1/2, or you can say 0.5. All right, let's look at the probability that B occurs. So we have 8 occurrences in B divided by the 12 in the sample space. 8 over 12 is divide by 4, you get 2/3, or 0.66 repeating. Right? Okay, let's look at the next question. A and B. Okay, so A and B means all the occurrences that are common to both A and B. Okay, so we see that nothing that starts with a 1 is common, but we have 2, 2 is common to both. 2, 4 is common to both. 3, 1 and 3, 3. All right. Now, A or B means everything that's in either A or B or both. Okay, so we're collecting all the different ones together. Okay, so they don't have to be common. It either has to be in A and B, and it could be in both. Okay, so looking at the A ones, we have 1, 1, 1, 3. Then we have 2, 1, and 2, 2, and 2, 3, and 2, 4. All right, and we have 3, 1, 3, 2, 3, 3, and 3, 4. All right, so those are in either A or B, or they could be in both. All right, now probability of A and B is how many occurrences you have in A and B divided by how many in the sample space. So here I have 4 over 12, or 1/3. Right? Probability of P of A or B, that's going to be how many in A or B divided by the total. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 12. Or if you simplify it, this is 5 over 6. All right, let's look at the next one. B prime. B prime means all the occurrences that are in your sample space but not in B. So if you take all the B occurrences out of the sample space, what's left over? So B has all the 2s and all the 3s, like with the first terms. So, but it doesn't have any of the ones starting with the 1. So this is going to be 1, 1, 1, 2, 1, 3, and 1, 4. Right. Probability that B prime occurs is how many in here divided by how many in the sample space. 4 over 12, or 1/3. That's a 1. All right. Okay, now we want PA plus P prime of A. Okay, so I know that probability of A is 0.5 or 1/2. See, probability of A prime is all the stuff that's not in A. So here I have 1, 1, 1, 3. So it's basically where the sum of the numbers is odd, right? So it's the opposite of the ones where the sum is even. So this is 1, 2, 1, 4, 2, 1, 2, 3, 2, 4 is even, 3, 1 is even, 3, 2, and 3, 4. So there's 6 occurrences here. PA prime is going to be 6 over 12, which this is also 1/2. So 0.5 plus 0.5 equals 1. All right, so notice the probability of an event plus the probability of its complement is always going to be 1, right? Because event and its complement are like complete opposites of each other. They're going to, together, they're going to make up the entire sample space. All right, let's look at this. PA given B and PB given A, okay? So PA given B, so given B, basically means that you're going to look, B becomes your sample space, right? And you need to look at the event A within that sample space. So just looking at the B of events, you want to pick the ones whose sum is even. Okay, so this will be 2, 2, 2, 4, 3, 1, and 3, 3. Alright, so 4 of those are in A out of all the ones in B, and there's 8 of them. So this is 1/2. So this is called conditional probability. Conditional probability reduces the sample space only to the elements in B. So when you divide it by how many things in the sample space, you don't take the original one, you take that set in the second place, right? And PB given A becomes my sample space. And out of here, you want to identify the B's, which is that it starts with a prime number. So here we're going to have 2, 2, 2, 4, 3, 1, and 3, 3. Right? And so there's 4 occurrences out of the 6 from A. So this is 2/3. Right? And no, they're not equal. Right? So probability of A given B is almost always not equal to the probability of B given A. Alright.